I'll record this soon. All right, so I want to share screen, share this screen, and let's take a look. So it's Tuesday, homeroom day, 15th. The school board's meeting tonight on how we're going to handle coming back, I believe. So some of you might be excited about that. They're going to vote and see what the idea is. So if we take a look and discuss the answers to the Mullen Stoic review, if you have a question like Davis did, by all means, I can answer that during this time. At the end of this, I'm going to go through a few problems. So if you want to stick around and watch me work a few problems, if you're not getting every little aspect of it, that may help you. If you're not sticking around, you're going to go ahead and go off to the magnesium oxide lab. The actual sheet to complete is right here. And this sheet is just the data sheet. So you can see here, here's Mr. Jackson, your lab partner. This is just the data sheet. So during the laboratory itself, here obviously is the MYP indicators. Here is the background and procedure to the laboratory. So it's right below that video. And unfortunately, this video ends up being about 11.5 minutes. So that you will have to go through 11.5 minutes to pull that data out. And then you submit that just as you have submitted PDFs before. Let's take a look at when I want that by. I want that by September 16th, please. By September 16th. Obviously, as you turn them in earlier, the grade is a little bit easier. It's softer on you, so keep that in mind. The earlier I get it, usually I'm easier on grading it. So I realize you're taking basically the brunt force of turning it in early. You haven't had as much time to discuss with your cohorts. If we take a look tomorrow, we will be reviewing any problems with the content, and that's just basically what students want me to review. By then, under this, there will be the answer sheet to all of that review. So if that's how you work better, by all means, if you work better by watching me work through problems, that's not a problem either. And that is for Thursday's test. Friday, we have the movie. Let's take a look. One thing I may not have mentioned to you is that the Mythbusters Deep Dive, it has a worksheet that's only worth 18 points versus the Mystery of Matter worksheet is actually 30 points. So just keep in mind that, oh, Mythbusters is winning. But look at this, Mystery of Matters is making a comeback. 1, 2, 3 versus 1, 2, 3, 4, 5, 6. So just keep that in mind. If those 12 points that you're like, I could use 12 points, then you would want the Mystery of Matter over the Mythbuster. And I'm just saying that that's right now. I mean, we may end up, like, let's say I get sick, then I may shove out the other video that I didn't show. So just keep that in mind. I mean, the 12 points may come back, but whatever. The test, I'm pretty proud of this test. I spent a lot of hard time making it. So what I've done is, I'll just run through it real quick. What I've done is I've replaced 5 questions that we would normally take if we were in the classroom for 57 minutes. I've replaced 5 questions. So instead of having 25 of the math and relationship questions, you only have 20 of those. Now, to offset the amount of points that those questions are worth, what I did was I added in some matching questions that are like definition, like what is stoichiometry? What is, the theoretical yield? Some questions that you can answer pretty quickly, but still get the point value of that up. It ended up coming out to be 96 points. So we'll see about that. I made it from a 57-minute question by deducting those 5 questions. I made it a 45-minute test. Since we have 45 minutes plus 10 minutes of passing period each way, I am giving you 55 minutes to take it. So that means that if you're like logging in a little bit earlier, you can log in and get ready to take it right at, that's Thursday, so that would be at 1:05. I'm sorry, that would be at 1 o'clock. Let me make sure I have that set up right. That would be at 1 o'clock. Don't look at any of those questions. And it looks like I haven't set that up yet. So I'll set that up so that you guys can get on at 1 o'clock. And then you'll have until 1:55 to complete it. That will give you the whole 55 minutes. Keep in mind that this test, in reality, in my opinion, it should only take 45 minutes to complete. But if you're somebody that is always working over the bell on tests like this, then make sure you take that into account. Obviously, if you have extended time, I will add that separately, and you will have to take your test after school, just because there won't be enough time. And with extended time on this, that will give you 63 minutes. So keep that in mind. All right, I think that is it. Are there any questions about any of that? I feel like I said all of that in a decent way that it could be understand. But if you don't know a lot about tests and stuff like that, then yeah, it may not mean that much to you. No questions about that? All right, if you want to break off then and hit the laboratory, by all means, go for it. And then if you want to stick around and you want to check out this, you work through some problems, by all means too. There is one question, Armari. When will the hydrate lab quiz be in Skyward? That will have to be after I grade it. So after I grade it, I will put it into Skyward. If the question is, when will I be grading it? I will be at least I will be grading 2 things tomorrow for this class, and it'll be whatever 2 things are next. If that falls in there, I'll be grading it tomorrow. If not, it will most likely be on Friday while you're watching the movie then. But Friday, I plan on getting all the way up to the test we have Thursday in. So if that's your question, your grades should all be updated by Friday of this week. Cool. All right, I'm going to do a few of these problems. I'm going to do one of these limiting reagent ones. This is on page that looks like this on the review guide. So let's take a look. Limiting reagent. When 7.24 moles of magnesium and 3.86 moles of oxygen react to form magnesium oxide, which reactant is limiting? How many moles of excessive reagent are left over? Oh, you are a hard one. Real cool. Thinking of like that test I made, I did make a really cool problem. Remember, you know when something is combusted, that it reacts with oxygen and it produces carbon dioxide and water. So I actually just say something that's very similar like this question. I say, so if this many moles of CH2 combust, that would mean you would actually have to make this reaction for the combustion of CO2, balance it, or CH2 or CH4, whatever, and balance it, and then work this problem to get the answer. So we have this much magnesium, and we have this much oxygen. We want to see how much magnesium oxide we can form. So every 2 moles of magnesium oxide, wow, this is actually the lab today. I'm giving you like, yeah, if you stick around for this, get a little bit of a benefit on the lab today. Every 1 mole of O2 is 2 moles of magnesium oxide. And every 2 moles of magnesium oxide here is 2 moles of magnesium. So that will tell us how many moles of magnesium oxide each of these can make. So this is just going to be 72.24 because the 2 and 2 will cancel out. 3.86 times 2.
The answer is 7.72.
7.72. So out of these two, which one can we actually make?
Magnesium.
All right, so let me ask that question one more time. Out of these two amounts, which one can we actually make? Magnesium is not one of these two amounts.
The first one?
Yeah, that's the answer we're looking for. We can only make this 7.24. Now to go with what Davis said, why can we only make 7.24 moles of this?
We don't have extra.
Yeah, because magnesium is the limiting reagent, right? So that I'm going to make sure that we're clear on that. The answer to the which reactant is limiting is the magnesium, but the actual amount of this we can make is this. This would be considered then what we call the theoretical. That would be the theoretical. So then it says how many moles of excess reagent are left over. Well, every 2 moles of magnesium oxide require 1 mole of O2. So if we were to make 7.24 moles of magnesium oxide, this would tell us how many moles of O2 it would require. 7.24 divided by 2.
It's 3.62.
So we need 7.24 moles of magnesium and 3.62 moles of O2. Well, we have 3.86 moles of O2. 3.86 minus 3.62.
It's 0.24.
So how much reagent do we have left over? We have 0.24 moles of O2. Because when we reacted this, we got this much magnesium oxide. So that means it took this much oxygen to do that. Since we had this much oxygen to start with, the amount of oxygen left over is this 0.24 moles. Kind of cool. All right, let's do a few of these. What is the mass of 0.800 moles of magnesium nitrate? So the first thing you need to know how to do for this is to be able to write magnesium nitrate. Just like that. 6 times 16 plus 14.01 times 2 plus 24.31.
The answer is 148.33.
148.33. That's equal to 1 mole. So I have 0.800 moles, and every 1 mole is 148.33 grams. But when I'm looking at this, the only one that really kind of makes sense is probably this 119, but let's go ahead and check that. 0.8 times 148.33.
That would be 118.664.
So the answer for that would be D. Given the unbalanced chemical equation, which one of the following correctly expresses the mole ratio between CO and oxygen? So this says unbalanced, so that means I need to balance this. So we need a 5 here, and we need a 6 here. And that gives us 5 plus 6, which is 11. Half of 11 is 5.5. So we're going to multiply everything by 2. So that's a 2 to to 11 to 10 to 12. So, which one of the following correctly expresses the mole value between CO and oxygen? It should be 10 moles of CO, 10 moles of CO to 11 moles of oxygen. A hydrocarbon, a compound consisting solely of carbon and hydrogen, is found to be 85.6% carbon by mass. What is its empirical formula? So if it is 85.6% by mass, that means every 100 grams is 85.6 grams of carbon. 100 minus 85.6.
The answer is 14.4.
And 14.4 grams of hydrogen. Because it's a hydrocarbon, it consists solely of carbon and hydrogen. If this makes up that percent, the rest of the 100% must be hydrogen. Now, remember the steps here. We got to get these to moles. And then we divide by the least number of moles. 14.4 divided by 1.01.
It's about 14.2574.
So that's how many moles of hydrogen we have. 85.6 divided by 12.01.
It's about 7.1273.
Dividing each of these by the smallest number. 14.257 divided by 7.127.
It's about 2.0004.
So that's close enough to 2. And the amount of carbon is close enough to 1. So the formula is CH2. P. This would be done the same exact way. So I'm going to skip that for now. I will give the answer to that for tomorrow. A 3 mole sample of this was decomposed. And according to this equation, how many grams of O2 are formed? So we have 3.0 moles of KClO3. Every 2 moles of KClO3, that's potassium chlorate, by the way, very powerful oxidizer. Every 2 moles of KClO3 gives off 3 moles of oxygen. I think whoever's doing this is kind of funny because why would you want the mass of oxygen? Oxygen's a gas, but maybe they're collecting it in a device that they know the mass of already. Every 1 mole of O2 is, since it's diatomic, remember, it is 32.00 grams of O2. 3 times 3 divided by 2 times 32.00.
That would be 144.
2 significant digits, that gives us 140 grams of O2. Huh. I was hoping that there was a problem dealing with theoretical yield. Here's one. A chemist burns 160 grams of aluminum in excess of air to produce 260 grams of to produce aluminum oxide. 260 grams of product are produced. So that right there is telling us what he actually got in the laboratory. By using this 160 grams of aluminum, we can figure out the theoretical yield. So 26.98 grams of aluminum is 1 mole of aluminum. From this balanced equation, every 4 moles of aluminum is 2 moles of aluminum oxide. And every 1 mole of aluminum oxide, 3 times 16 plus 2 times 26.98
It's 101.96.
is 101.96 grams of aluminum oxide. 160 divided by 26.98 times 2 divided by 4 times 101.96.
It's about 302.3276.
302.3. And since we're changing this to percent, remember we just round all of the percents to 2 decimal places. So I'm going to go ahead and leave that like that. So remember, I take the actual over the theoretical and I multiply that by 100. So 260 divided by 302.3 times 100. Oh, that's not how you make a percent sign. 260 divided by 302 times 100. 260 divided by 302 times 100.
It's about 86.0927.
So 86.09%. That's what percent of that I got. I should have been able to make 302. I was only able to make 260. 86% is still a lot better than I think I got in the laboratory that you guys are doing tonight. Questions there? Anybody want to see any others? Yeah, go ahead.
Why didn't you do 302.3 and you rounded it to 302?
I could have. Let's do it. 260 divided by 302.3. 260 divided by 302.3.
It's about 0.86.
So what I would end up getting is 86.01 instead. That's fine. The deal is that we always go out 2 decimal places on percent. So I mean, it wouldn't matter that much, but that's good. Others? All right, so if you want to see me work any of the other problems, by all means, point one out. But other than that, I'm going to try to get some grading done. And then I'll get this, I will get all these done by tomorrow though. So you guys probably have enough time to go ahead and still finish that laboratory. It's 2:03 and you've got until, you got 20 minutes. The video is 10 minutes. You could probably get it done.
So for the lab, we just complete the sheet, right?
Yeah.
Okay.
Take the sheet and turn it in, yep. Alexa, shuffle my playlist school songs.